Welcome. Before going into the wattmeter chapter, which is solely used for power measurement, we need to have a brief idea on power. See, generally in electrical system, power is of two types. One is AC power, another is DC power. So let us have this circuit. Here the supply is given to a load, and when the supply is connected with the load, a current I is flowing through the circuit. Let us assume the supply voltage is suppose V. So at any instant, the power consumed by this load is equal to voltage multiplied by, that means P equal to V into I. So multiplication of power of voltage and current generally gives us the value of power, but this thing is not so easy. If the supply voltage is DC, then only this equation validates true. But if our supply system is AC, then there is a lag between voltage and current due to inductance present in the circuit. It may be in the load, it may be in the supply line. Okay, so for AC power, our expression of power or the consumption of power by the load will be equal to VI cos phi. Cos phi is the power factor. Now let us understand this with waveform. In AC, suppose we have a sinusoidal voltage V, as well as we have a sinusoidal current flow, that is I. Whatever I have said, there is a lag between V and I in case of AC system due to the presence of inductance in the circuit or the system. So what is the lag? This is the lag. When voltage is starting from its initial zero position, current is not starting from zero position, it is starting from this particular instant. Okay, this angle is called phi. This x-axis is omega t axis. So cosine of this angle phi is called cos phi. So for a single phase power, when there is a voltage and a current, then AC power is equal to VI cos phi. So if we try to draw the AC output or output power, that will be equal to like this. So this is the power waveform. One thing we need to understand, that in case of voltage, average voltage is equal to 0. Why? Because the area covered by the positive half cycle of voltage is equal to the area covered by the negative half cycle of the voltage. Similarly, in case of the current, area covered by the positive half cycle of the current is equal to area covered by the negative half cycle of the current. I have shown here with shade. Clear? So current, average current is also equal to 0 for a sinusoidal voltage wave or current wave. But see, in case of power, average power is not equal to 0, or rather VI cos phi, as the positive half cycle of the positive part of this power is not equal to the negative part of the power. So average power always remains with some value whenever you try to calculate, and whenever it is a three-phase power, then it is √3 VI cos phi. This is the three-phase power expression. For that we need three separate voltages, that is RYV, and for three separate currents, then only we can obtain the three-phase power consumption. So I think the elementary concept of power is clear to you, the difference between AC power and DC power, as well as the power factor, average power, average voltage. These things are clear to you. Now we have to know how many types of power are there. Generally three types of power are there. One is apparent power, another is active power, and another is reactive power. The expression of apparent power is equal to VI, active power is equal to VI cos phi, and reactive power is equal to VI sin phi. So our wattmeter is used to calculate this active power, or Vi cos phi. This is the power which drives the load like fan, light, motors. All these loads are run by this active power, and wattmeter calculates the value of this active power. And the summation of active and reactive power is equal to apparent power. Reactive power is basically or mainly used for creating magnetic flux, which is very important thing in induction motor or transformer. So I think the concept is almost clear to you about the necessity of power as well as its measuring technique using wattmeter. It is not that we can't measure the reactive power. There is a small change in connection of wattmeter. We can measure the reactive power also. So in the next lectures we will be understand the different aspects of wattmeter and power measurement. Thank you.